Assalamualaikum and good day to audience and judges. My name is Muhammad Fauzi and I was assisted by other co-researcher Nur Hayati, Dr. Firdaus and Prof. Ayub. Today, I would like to share our study entitled Performance Evaluation of Drip Irrigation System and Water Productivity of Rock Melon Grown Inside Netted Greenhouse Shelter. Malaysia uses 76% of their freshwater resources for agriculture purpose. It is estimated that water demand in Peninsular Malaysia will increase 63% in 2050 compared to year 2000. Due to human growth population, food need will increase 100% to meet the needs of 9.8 billion people in 2050. The concept of drip irrigation system is it supply water and nutrient directly to root zone. It uses 30 to 50% less water compared to sprinkler system. It has huge potential to be applied during drought season and limited farming area. Save water, higher irrigation performance, and efficient use of water and fertilizer are the advantages of this system. However, this system also has several drawbacks. For example, it is more complex, needs proper maintenance, and more expensive. Based on observation at the field, unused agriculture structure for a long time due to electricity problem and water resource issue may affect irrigation efficiency. Drip irrigation system is easy to be clogged. Therefore, crop production will decrease due to these obstacles. Three objectives of this study are to evaluate the performance of drip irrigation system for rock melon under newly developed, unused and abundant rain house shelter with and without crop. Second, we want to estimate water productivity of rock melon cultivated under rain house shelter in tropical area. And third, to determine relationship between opening and closing valve to the discharge and pressure resulted in piping system. We tried to answer three research questions for this study. What are the current status of drip irrigation performance for newly developed, unused and abundant rain house shelter with and without crop? What happened to the water productivity of rock melon respected to the irrigation performance, and how valve closing and opening can affect the pressure and discharge of drip irrigation system. Although extensive research has been done in evaluating drip irrigation performance, this is still much scope to be explored. For instance, situation for unused and live cultivation house at certain time. To answer research question, we conducted field experiment and measured some parameters, for example, pressure and discharge. SPSS was used and data was analyzed by using sample t-test and ANOVA. This study was conducted at Agro Technopark UMK. Drip irrigation consists of water tank, main line, lateral line, valve, fluid meter, pressure gauge, and 2 horsepower pump as shown in schematic diagram as follows. 100% cocoa has been used as growing media. Fertilizer A and B was applied as recommended by rock melon SOP. Crop maintenance was done as normal practice by farmers. The coefficient of variation is used to measure the variability of load in the drip irrigation system. How water distributed efficiently was calculated using application uniformity equation. A separate experiment was performed to evaluate the effects of closing and opening of the valve at lateral to the discharge rate at different scenarios as shown in this table. At the end of this study, we know drip irrigation performance and water productivity of cultivated rock melon. The operating pressure of the system tested varied from 0.8 to 3.0 psi with discharge between 0.14 to 0.25 liter per minute. We found working pressure 1.5 times higher for normal practice of 300 polybag. The use of control valve was solved this matter, but it causes losses in power consumption and expenditure wastage. We recommended to replace 2.0 horsepower pump with 0.5 horsepower pump. In general, CV values were mostly classified as very good and acceptable in both conditions. It seems that CV estimation without crop showed lower values and duration taken to estimate it influencing these values. CV values obtained with cropping can be classified mostly as the good and acceptable performance. Different categories of CV could be observed because of manufacturing variability, clogging due to the suspended fertilizer and damaged emitter. It can be observed that CV without crop has a lower value than CV with crop cultivation. Past sample t-test shows significant difference of CV between these two conditions. Frequently flushing for whole cropping season guarantee each plant obtain the same amount of irrigation water every day. Flushing was needed to remove the accumulation of sediment. AU between lateral with crop condition has average of 74% and it was classified as fair. AU between lateral without crop has average of 81%. 60% of lateral without crop condition were categorized as good and others as fair and poor. AU could be declined due to defective of irrigation pump, broken or twisted distribution line, obstruction in the dripper or filter, corrosion of part in irrigation system, and inadequate design. Past sample t-test showed significant AU on lateral 3 and 4. However, AU did not significant at lateral 1, 2, and 5 for both conditions. This result might be due to the same pressure magnitude at the beginning and at the last of lateral point. The design and management of irrigation system not the only factor that influence water uniformity, but it could be from hydraulic gradients existing within the wetted soil which affect the water movement. Water productivity for rock melon was estimated to be 7.93 kg per meter cubic. The high value of water productivity means high yield can be produced with low amount of water applied. Different studies found that water productivity values around 7 to 30 kg per meter cubic or even lower depend on experimental conditions. Water productivity obtained in this study is in an acceptable range, and this variation might be due to different field practice and irrigation frequency applied. We found that the mean of discharge was not significant among the head, middle, and tail section. The mean discharge for head was reported to have the highest value compared to the middle and tail. Droplet of water at the head section had the highest average discharge due to the nearest point from water resources. In summary, Irrigation performance and water productivity of drip irrigation system was successfully evaluated. Water productivity found is in line with the predicted water productivity value in the previous literature. Most of the lateral lines perform well and some need to be monitored periodically, especially during the growing process to prevent clogging. The result demonstrated variation of water application uniformity and water coefficient variation between lateral lines, although they are located in the same fertigation system. Performance irrigation should be evaluated continuously from the beginning of the greenhouse completion until current usage for detecting any abnormalities and leakage of the irrigation system. I would like to acknowledge institutions' facility and financial support in this study. You can simply reach us through the following platform for detailed study. Thank you.